Hey everyone, and welcome to The Explainer. I'm absolutely thrilled you're here with us. Today, we are getting into something that has literally been a game changer for how developers work with artificial intelligence. We are talking about LangChain. If you've ever played around with a basic AI text box and wondered, okay, how do I actually take this from a simple chat interface to a complex, data-aware application that can do real work? Well, LangChain is your ultimate toolkit for that.
To really get LangChain, we have to anchor ourselves on what it actually is. It's not an AI model itself. It is a framework. It basically acts as the connective tissue bridging existing large language models, think OpenAI or Anthropic, to the real world. Think of it as the scaffolding that lets you build chatbots, autonomous agents, and data-aware systems by plugging these powerful models directly into your specific tools and your private data.
Okay, let's dive into this. Today we're taking a bottom-up journey. We're going to cover the core blocks, linking steps, smart controllers, the power of memory, and finally, retrieval augmented generation.
Starting right off with Section 1, Core Blocks, which means models and prompts.
As you know, every great app starts with a rock-solid foundation. Before your application can do anything at all, you've got to configure your base language model block. The beauty of LangChain is that it gives you a unified interface, so whether you're talking to OpenAI, Grok, or Anthropic, the setup looks remarkably similar. You pick your model, and then you tweak the critical parameters. Take temperature, for example. Adjusting this dial transforms the AI from a strict, highly factual engine at a 0.0 setting to a much more wild, creative generator around 0.8. You also set your max tokens to keep the response length exactly where you want it.
Once you've got your model dialed in, you need to talk to it. But honestly, manually rewriting prompts every single time, that's just a surefire way to repeat yourself, forget crucial instructions, and make errors. Instead, LangChain uses prompt templates. These are brilliant because they let developers create reusable, consistent instructions using dynamic placeholders, like a variable for a specific topic. It means your app stays safe and incredibly easy to maintain. You just update the wording in one spot, and it perfectly applies everywhere.
Moving on to Section 2, Linking Steps, where we build chains.
So, we have our models and our templates, but to build something that actually works, we need to link them together into a workflow. A classic LangChain chain follows a really clear sequential flow. Step 1, you take the user's input and insert it right into your prompt template. Step 2, you call the LLM with that beautifully formatted prompt. And Step 3, you pass the model's response through an output parser. This is exactly how you build a reliable, reusable pipeline.
The absolute best way to think about a chain is like a fixed recipe in a kitchen. The steps are entirely predefined and they do not change on the fly. You, as the developer, are the head chef deciding every single step in advance. The flow is completely predictable and hard-coded.
And this brilliantly illustrates why that final step I mentioned, the output parser, is so absolutely crucial. When an LLM replies, it almost always just spits back raw, unpredictable text. But in real-world software, you can't build a reliable app on messy text blocks. Output parsers force that raw text into structured data. They can strip away quotes to give you a clean string, format the output into a Python dictionary, or even enforce a strict JSON object structure that your downstream app can actually read and use. It's basically magic for taming AI outputs.
All right, Section 3, Smart Controllers. Let's talk about LangChain agents.
Now, chains are fantastic for tasks you can predict, but what if the task isn't predictable? This is where we have to contrast chains and agents directly. As we just saw, a chain has a fixed flow. You decide the next step. It's simple. An agent, on the other hand, acts like a smart, autonomous assistant. The flow is entirely dynamic. The LLM itself becomes the brain, deciding what to do next based on whatever the user asks. It's incredibly powerful because it actually reasons through a problem, even though, it is inherently a bit more complex to build.
So how does an agent pull this off? By wielding tools. You essentially hand the agent a tool belt, maybe a function to search Google, query your private database, call an external weather API, or just use a calculator to do math. The agent reads the question, decides if it needs a tool, picks the right one out of the belt, calls it, looks at the result, and then figures out its next move. It is a massive superpower for multi-step reasoning.
Let's jump into Section 4, the power of memory.
Whether you are building a straightforward chain or a highly dynamic agent, you are inevitably going to run into a fundamental roadblock. LLMs are completely stateless. Every single time you send a request, it's like meeting the model for the very first time. Imagine having a chat where your first message is, "My name is Chandra." Then, for your second turn, you just ask, "What is my name?"
Now, what's really interesting about this slide is the AI's response. It fails completely. You did not tell me your name.
Boom! Without memory, the AI has instant amnesia regarding turn 1 of the conversation. It has zero context. It's essentially like talking to a goldfish that happens to have a supercomputer for a brain.
Fortunately, LangChain solves this amnesia problem automatically by offering a few different memory styles. What it does is inject that chat history right back into your prompt. You've got the conversation buffer, which simply stores all previous messages as is, perfect for short chats. For longer chats, a conversation summary actually uses an LLM in the background to summarize older messages so your prompt doesn't get ridiculously bloated. Or you can go with a hybrid approach, keeping the most recent messages raw while summarizing the deep past.
Which brings us to our final stop, Section 5, Retrieval Augmented Generation.
Okay, so we've got models, templates, chains, agents, memory, the whole shebang. Now for the absolute most powerful building block, giving the AI access to a private library of knowledge. We call this pattern Retrieval Augmented Generation, or RAG. It perfectly solves a massive problem, which is that LLMs only know what they were trained on. They have no clue about your company's private PDFs, real-time databases, or internal notes. RAG bridges that gap. At query time, it retrieves relevant external data and feeds it straight to the LLM, effectively attaching your custom knowledge to the model without needing a ridiculously expensive full model retrain.
The real secret sauce making RAG work so beautifully is how it searches. Traditional keyword search needs exact word matches, but LangChain utilizes semantic search using things called embeddings. Embeddings convert text into numerical vectors where similar meanings are actually grouped together. So, the system inherently understands that a search for iPhone maker is semantically super similar to a document talking about an Apple company, even if the exact words don't match up at all.
Let's walk through this workflow step by step. It's like a giant puzzle. First, you load your massive documents. Second, you split them into smaller, digestible chunks. Third, you convert those chunks into embeddings, those numerical vectors we just talked about. Fourth, you store them in an index, like a vector database such as FUS. And finally, when a user asks a question, the system converts that question into an embedding, retrieves the most mathematically similar chunks, and hands them right to the LLM to craft an incredibly accurate answer.
So the crucial point here is just how elegantly LangChain lets developers stitch all these concepts together today. It's called LangChain Expression Language, or LCEL. By simply using Python's pipe operator, you can just declare chain equals prompt, pipe, model, pipe, parser. It treats every single component as a composable piece, letting you snap together incredibly complex pipelines with really clean, readable code.
And hey, once your app is up and running, you need to see what it's actually doing under the hood, right? LangChain provides callbacks for monitoring. These act like event listeners. They let you log inputs and outputs, measure system latency, debug those complex multi-step agents we talked about, and, maybe most importantly for the user experience, stream tokens in real time to your front end. That gives you that super satisfying typing effect as the AI generates its answer. So we've covered the core primitives, the models, the prompts, the chains, the agents, the memory, and the immense power of RAG. LangChain doesn't replace the AI. It gives you the absolute best framework to control it, to scale it, and to connect it to reality. It gives you the building blocks. The only question left is,